Hello, everybody, and welcome to another YSI webinar. We thank you all for coming out. We realize that this might not be the most appropriate time zone for you, so we do thank you for joining us wherever you might be. And of course, we are recording this webinar, and this webinar recording will be available to you and to anyone who's registered. There will be a follow-up email approximately 1 hour after this webinar concludes, and that email will include a link to the webinar. You can also find a copy of this presentation on one of our regional websites, or simply contact our marketing team. Our email address will be presented to you on the final slide of today's deck. Simply reach out to us. We'll be more than happy to share that copy of the presentation with you. So today's presentation is entitled Precision HydroMet Instrumentation, and our main presenter today is Kerry Hubbard, who is from YSI. She's our outdoor water monitoring specialist and has over 10 years of HydroMet monitoring experience. She's definitely the go-to person in our business concerning this topic, and she has a huge passion for urban hydrology. My name is Michael Watt, and I'm the host for today. We have a truly international webinar today, as I am based in Tokyo, where it is currently 10 a.m. on Thursday morning, and Kerry is based in Carolina, USA, where it is 9 p.m. So, and of course, all of you are coming, I'm sure, from different time zones. So again, thank you very much for joining us. We have quite the webinar prepared for you today, and let's just quickly go over through our transmission order. We'll be discussing submersible pressure transducers, shaft encoders. We'll be discussing our YSI Amazon bubbler, as well as introducing our Nile radar level sensor, together with our Storm 3 data logger, and also spending a bit of time today introducing you to our newest data visualization software called the HydroSphere. And without further ado, Kerry Hubbard, thank you so much for joining us today.
Excellent. Thank you guys so much for having me. I'm really excited to be here and talk to you guys about hydrometeorology. So first, we'll just start off talking about what that actually is. Because our entire presentation today is going to be talking about some of that precision HydroMet instrumentation that we have to offer. So hydrometeorology is the combination of the studies of meteorology and hydrology and relates the transfer of water between the atmosphere and land. So an example of this is listed here and depicted roughly in the images here. So if a meteorologist depicts 5 inches of rain, like the Yellow River received during the recent hurricane that passed through, a hydrologist can actually determine the impacts on the surrounding area. So the maps on the left here are from USGS flood inundation maps, and the modeled area for the project is depicted by the red lines. So as the amount of rain increases, the water level, of course, is also going to increase, and you can see the river expanding as that modeled precipitation runoff is greater in the second image when compared to the first. So these two branches of science, when combined together, can really provide you some accurate information to predict flood damages and are also useful in many other instances, as we'll get into now. So I think first, however, we are going to have a poll. Michael?
Thanks, Kerry. Yes, let me launch that right now. So our first poll question is, please indicate where you conduct the majority of your monitoring. For those of you who are new to the polling system, simply move your mouse over the response that you'd like to make and click on it. It's as simple as that. Our possible answers are streams and rivers, groundwater, lakes and reservoirs, wastewater, or others. So we'll just give you a few seconds to click in your response. Okay, Kerry, it looks like most of the audience has responded. I'm going to share the results. And it looks like the majority of our audience are conducting majority of their monitoring with regard to streams and rivers at 64%.
Excellent. Yeah, that's definitely the vast majority.
Yeah, this is followed closely by, between lakes and reservoirs and wastewater,
Perfect.
14% and 13%.
Excellent. Yeah, that's a really good mix. I'm glad to have a wide swath of users on this webinar today. All right, so we will pop into our first sensor then. Like Michael talked about with the agenda, we're going to talk about 4 sensors today. So the first one that we're going to talk about is the submersible pressure transducer. So as the name suggests, the pressure transducer portion of this instrument is actually intended to be submerged in the water. So this portion up here at the top of the image is the pressure sensor, and it connects directly to the sensor cable, which actually holds the communication and the power wires and also a vent tube. So the sensor cable connects to a dry air junction box, which is down at the bottom of the image here, which holds some desiccant packets to keep that vent tube dry, and it also has the vent port to allow for air exchange with the atmosphere for a proper barometric pressure compensation. So one extremely nice advantage to this pressure transducer over other models of submersible transducers is the ability to provide that on-site barometric compensation. What this means for you is that the data is highly accurate upon collection and no additional corrections need to be applied for that compensation. So it also has a stainless steel design, which is going to resist corrosion. And another important thing to know about the sensor is that it really has to be deployed in a no-flow environment, such as in a stilling well or a groundwater well. So in this image here, the sensor is actually deployed inside this giant metal pipe, which is going to be removing all flow influence, which provides a still environment for the sensor to read its measurements in. So like I mentioned before, we set these sensors up in a stilling well or other still water environment. So the pressure transducer at the end of the cable is going to measure the water pressure, and then the sensor compensates for changes in barometric pressure measured internally as air is exchanged in the vent tube. And again, all of these calculations are performed internally, so the data that you receive is going to be extremely accurate. So now in this image here, we can actually see a stilling well deployment in Europe. So this station is able to accurately measure the level of water moving through the area from storm flow and also due to pumping into surrounding fields. So that's just a brief overview of our submersible pressure transducers. Our next sensor that we're going to talk about is the shaft encoder. So this instrument in the image here is the shaft encoder. So it doesn't measure water pressure like our submersible pressure transducer does, but it actually instead uses a weight and float system to measure the level. So the pulley wheel at the top actually holds a tape that a float and weight are attached to, and as the water rises and falls, that pulley is going to turn and a water level value is going to be computed through the use of some optical instruments inside the electronics housing. So there's an LCD display that shows what the current water level is, and the read button is going to request a new measurement from the sensor and update that value. The adjust knob also allows for easy adjustment to the sensor readings when deploying. And this portion down here at the bottom is that output connection where the data would be transferred from this sensor to your data logger. So one huge advantage of the shaft encoder is that this one in particular is an optical encoder, which means that the encoder measures absolute position rather than change in position. So we're going to cover this a little bit more in the next slide when we talk about how the sensor works. Also, because of this technology, if power is lost to the sensor, the position itself is not lost. So no visits to the gauge are necessarily needed for a small power blip in order to reset the sensor, which is really cool. So there's also several requests that come in every year about using other pulleys or tapes with the sensor, and that is also definitely possible. So I wanted to throw that out now. And finally, similarly to the submersible pressure transducer, the ideal deployment for this sensor is in that same type of stilling well. It is not ideal for turbulent environments, and changes in water level that are too fast for any model of the sensor can actually cause that tape to slip off of the pulley. So just be really careful and aware of your deployment conditions. So how this sensor works. So after you have the sensor set up in the stilling well, what's actually happening? So as the float rises, as you can kind of see in the picture here, the pulley is going to turn. So there are two non-contact encoders that determine the shaft angle, and there's a magnetic turns counter that counts the number of revolutions that the pulley makes. Internally, there's actually an LED that flashes through a circular barcode onto a sensor array, and then the image is then decoded into a unique position. So the turn counter monitors complete revolutions of that shaft. So by combining the measurements from that turn counter and from the optical encoders, from all of these sensors, really, an accurate absolute measurement can be calculated. So here's an example of how the shaft encoder can be used. So this is in Del Rio, Texas, where water rights are a really big issue. So water rights are permissions for landowners that give them the ability to pull water from a stream or a river. And these landowners are really limited on the amount that they can pull annually. So for example, if a farmer uses too much water when compared to his allotted amount, he's going to receive a fine and have to pay some money for using too much water. So therefore, it's extremely important that a precise measurement is used, and measuring the flow at a certain gate opening amount just doesn't always cut it. So water level at these sites out in Texas is correlated to a discharge rating, and those discharge measurements are made frequently, as can be seen in the image here on the bottom left. So high rain events and droughts can impact the discharge coming into a water body, so it's important to regularly measure that in addition to the water level to make sure that there's no changes to the channel geometry or anything. So you can see the small well that's installed next to the irrigation channel, and these shaft encoders are used as a really accurate way to measure that water level that, as mentioned, is correlated to a discharge and is then used to make sure that everybody follows the rules. So our next application is from Alameda County, California. So they used to use these really old, large shaft encoders and these kind of ancient data loggers as well. So the maintenance on this equipment was pretty extensive, and when monitoring for the purposes of things listed here like water rights and habitat sustainability and flood management, it's really important to have easy to use equipment that provides good data and quickly. So when it comes to flood monitoring, as sites lose communication, we can literally have lives in danger. Lots of lives are lost every year to floods and water. So this group actually replaced their old equipment with new equipment that's easier to maintain, and they're pretty happy to say that they now have better data than before, which has been proven to be useful in all of their applications listed here. So the next sensor that we're going to go over is the Amazon bubbler. So with this sensor, we're now back to talking about pressure transducers, but I want to point out that this one is actually a non-submersible pressure transducer. So let's dive in a little bit and see what those differences are between this sensor and the sensor from the first section. So the Amazon, like I said, is a non-submersible pressure transducer, and we say that because the portions of the instrument that perform the actual computations remain outside of the water the entire time in this fancy little box that is the Amazon. So we'll talk about how the bubbler is set up in a bit, but it was designed to be extremely user-friendly and has an easy-to-read screen and quick touch buttons and streamlined navigation, all the fancy bells and whistles that we all like to see and use every day. So on the bottom of the Amazon is actually where all the connections are. So there's a couple of USB ports for transfer of data and also for a Wi-Fi adapter connection. So there's also a place for the transfer of air into and out of the system on the left-hand side. And of course, we offer a few connection options such as RS-485, 4 to 20 milliamp signals, and SDI-12, so you can communicate to a data logger over a variety of signals. The key advantages to actually using the Amazon bubbler over sensors of the same type is actually the ability to connect with those many different systems, because it does connect and it communicate in those so many different ways, as I just mentioned, with the 4 to 20, the RS-485, and SDI-12. So the Amazon also has a special ability to store data internally, so it can even be deployed without being connected to a data logger, which makes it a standalone system, which is really nice for those deployments where you just need to get something out there real quick to look at the data later. So similarly to our other instruments, it's extremely accurate, and unlike some other bubblers, it doesn't require an external pressure sensor because it has one built in. So finally, it has two easy ways that it can be programmed. One is via the browser interface, or the other is the optional low power display that you can kind of see in the picture here. So the sensor is really great to use in streams and rivers and lakes, and an orifice line can be mounted along a stream bank or down a culvert wall as a couple of different examples. So the averaging time of this sensor can also be adjusted, which is going to account for any effects of waves or turbulence to provide you with the most accurate water level reading possible. So the difference between this one and the submersible pressure transducer is also that we don't have to have still water for the Amazon bubbler. So now a little bit about how a bubbler actually works. So this black and white image here on the top left actually shows an older model of the bubbler that our company used to carry, which is called the H3551. But the image is still really going to help describe the internal components and how the sensor works. So inside the bubbler is a compressor, and there's also an air holding tank. So the two of these working in conjunction are going to provide a continuous flow of gas bubbles through the orifice line that runs from the Amazon down to the water, as shown in the image on the right. So the amount of pressure that it takes to create this continuous flow of bubbles actually determines the depth of the water. So as you can see here on the slide, the equation used to compute this in essence is height equals pressure divided by specific gravity of the solution. Now, the Amazon also has an integrated pressure sensor to account for changes in external air pressure as well to always provide the highest accuracy data. So that's going to be accounted for in that equation too. So it's not quite as simple. So finally, the orifice line and the tanks need to remain really dry in order to work properly. So connected to that air inlet needs to be a desiccant canister as seen in the bottom image here. So the desiccant dries out the air that comes into the instrument and does need to be changed periodically, and typically you can tell when it needs to be changed by a color change in the desiccant itself. So I briefly wanted to show you what the browser interface looked like. This is one of those two ways that you can navigate through the Amazon to program it. So this is the main menu screen that you would access when you connect via USB or Wi-Fi to the Amazon from your computer, your tablet, or your smartphone. So when you're connected, you simply navigate to your web browser, and if you're not redirected immediately, there's a simple IP address to type into the address bar to get you there. So on the left-hand side of the screen are the menu options to change everything from things like purge pressure to purge interval. You can change your communications and a whole lot more. So now we have a couple applications regarding the Amazon, and the first one, we're back in California again. So now we are in Contra Costa County, California, which is near San Francisco. So the county employs several of our Amazon bubblers as a part of their flood monitoring network. They actually have a really large rainfall network that's used to monitor where rain has fallen, and the water level sensors are going to allow employees to monitor the flow and determine when and where the public might actually be in danger. So the creeks that they measure are typically fairly dry, so it's really important that they have a water level sensor that can handle rapid changes in water level, which the Amazon can do really well. So the team also highlighted that the Amazon is really easy to configure, and even though they do have that optional keypad, they actually prefer to use the easy to use GUI, the graphic user interface. So Hurricane Harvey was actually absolutely devastating to the city of Houston a couple years ago, with record flooding throughout the area. So the University of Houston has water level and flow monitoring locations throughout the area. And this station here at Oyster Creek recorded water level values well above flood stage. You can see the flood stage here in the greenish picture, kind of at the top near the bridge here, before all of the vegetation was actually torn out by Hurricane Harvey. So before the event, water at base flow really only flowed through the center channel of the bridge, as you can kind of see in this picture here. But the magnitude of the flow actually ripped out a huge amount of sediment, which caused the channel to change significantly. So these changes can typically be seen in the water level values before and after the event, and the Amazon bubbler recorded data accurately throughout this event, which provided great information for scientists and engineers on how to better prepare for the future. So you can see after the hurricane had passed through, we now have water flowing through 2.5, I guess, of these channels here. And you can see that the channel was able to be waded in before, and now it's definitely not. So now they're having to use an ADCP as opposed to a flow tracker to actually get their discharge measurements and be safe. So the final sensor that we're going to talk about today before touching on our data logger and our data visualization tool is going to be the Nile radar. So first off, for those of you that do know the Nile in this image is not in the proper mounting position, but it's actually a lot easier to explain some of the components from this angle. So on the right side of the Nile radar, that's where the electronics housing actually is. Inside that cover are all of those computer components that run that Nile. On the top or the front, whichever way you would like to look at it here, is where the optional keypad can be installed. And that keypad can allow a user to program the many features in the Nile, such as the echo tracking that we're going to talk about momentarily. On the left-hand side, we have the location for where the cable fittings are. So that's where the power and the communication cables are going to be routed to. And finally, there's the antenna horn. And that's where the microwave transmitter and sensor are actually located. So as you can see, there's a large amount of advantages to using the Nile over any of the competition. And so in this case, sorry. In this case, our Nile is actually really easy to install and use and maintain. It doesn't take a whole lot to keep it clean. It has a heavy-duty housing for those outdoor installs, and we have some images later that actually show where people normally would have put this inside a housing, but you actually don't need to because our product is so solid. It also will communicate with any data logger similarly to the Amazon Bubbler, and it has high accuracy up to 70 meters. And as you can see in the picture, we do have a few different versions here, and the different versions will allow you to measure up to different distances. This is also really good to be used in streams and rivers and lakes and turbulent environments because, again, similar to the Amazon, there's a lot of averaging that you can do with the Nile radar in order to get really good readings. Now, what you're going to need to do with the Nile is actually have an overhead structure similar to a bridge, or maybe you're able to build some kind of infrastructure piece to mount the Nile radar. But what you want is a piece of infrastructure that's not going to move around too much because, of course, any movement is going to affect your sensor readings. So, for example, if you have a really windy area, you don't want to just have it sitting on a fence post sticking over the creek. You want to have something really solid. So here's an example of a way to mount the Nile radar here in a very harsh environment that not all sensors would be able to withstand. So this is a salt mine in Western Australia, and as many of us have experienced, salts can definitely corrode equipment, making it unusable. So this sensor has been deployed for a pretty extensive period of time and has not been damaged at all. And note, like I said before, it's not even in a protective housing. It's sturdy enough to handle this type of environment completely on its own. But how exactly does the radar work? So it has an integrated microwave transmitter and sensor inside that housing that we had talked about earlier. So a microwave beam is sent out from the transmitter, and then it's going to reflect off of surfaces, and it waits for a return signal to compute the distance to the sensor. There we go. There's my little animation. So the distance to water is proportional to the time of the pulse, and it follows the equation here, which is distance equals speed of light times time divided by 2. So we divide by 2 because we want the distance to the water surface and not the whole distance from transmitter to water to receiver. And yes, the microwaves can be bounced off of other objects, but in the next slide, I'm going to talk to you about echo mapping and how the Nile can counter the effects of that. So like I just said, the signal from the Nile is going to reflect off of everything in its footprint. So remember we talked about the antenna horn in the spec sheet. If you take a look at that, you'll see that each of our models of radar actually have a different beam angle, and a different beam angle is going to lead to a greater beam width as you travel further from the radar. So for example, in our smallest unit, it has the largest beam angle of 3. At a 10-degree angle. So therefore, at a measurement distance of 20 meters, the beam width is actually 3.5 meters. In our largest unit, there's a beam angle of 8 degrees, which makes the beam width at 20 meters only 2.8 meters. So whatever the beam width is, that area is going to be reflecting the waves back to the radar. However, it's important to note that water has the strongest reflective signal of all objects, so it's going to return a high signal strength compared to something like the riverbank in this image. We can map out the interferences that have low signal strengths, such as appear in both banks, so that we always ignore those interferences and only look for the signal from the water. So this mapping is done inside the Nile itself through some fairly easy coding, and complete instructions for that with diagrams are definitely found in the manual. So as you can see in the image here, the original mapping is this blue line, or sorry, is this black line and the red line here, and you can see all of the different interferences, and then the big signal from the water here. So after mapping, we've said that, okay, I want to take out any interferences that are before my water level. So now I can see after the mapping, I have no interferences, and I'm only measuring that giant water signal right there. So there's definitely a lot of uses for all of these instruments, but I have a lot of application examples for the Nile radar here. So the first that I'm going to talk about is just that simple water level measurement. So here in the US and Chicago, they wanted to augment their water quality monitoring station with the addition of a water level sensor. So water quality changes can actually be better explained if there is accompanying water level data. So they installed a radar because it was non-contact, it was really easy to set up, and it required minimal maintenance. So now they have real-time dissolved oxygen and water level information to better determine what's going on at the site. So air gap measurements are very important for those in the marine transportation industry. So it's vital that ships know if they have the clearance to safely pass underneath a bridge. And one of the measurements that can be transmitted by the radar is that distance to water. So the Nile will actually give you two different measurements. One is air gap and one is water level, which can be related to depth, of course, through surveys. And by combining these two, safe passage can basically be guaranteed for these ships. If they don't have the depth, and if they don't have the air gap, they can't travel through this area and they have to wait. So the Nile is also really important for monitoring tides to verify high and how low the different tides are, which again can be really helpful for marine safety. So the tidal data can also be used to determine trends to see if water levels are changing over the years and what the effects of tidal change are on the ecosystem. So in this case, the Nile is using one of the NOAA modes, which collects a large amount of data and performs internal statistical analyses, which then lead to an accurate average data point. So what is NOAA mode though? I just mentioned that it's used for tidal measurements. NOAA mode is a special mode that was desired for accurate level measurement by the National Oceanic and Atmospheric Association here in the US. So in this measurement mode, the sensor takes 181 measurements at 1 second intervals. Then a bunch of mathematical computations are performed, as you can see listed here. The data is eventually sifted through and the mean and standard deviations for the 181 seconds are calculated. The radar can then output the mean water level, the number of outliers, the number of good values used in the calculation, and also that standard deviation. So here's another few images showing a deployment in fairly turbulent conditions. You can see that the sensor is actually exposed to the atmosphere, again showing that durability. And in that second image, they're removing the sensor for some maintenance. So I do have a little video here that I'm just going to try and take 2 seconds to play that just kind of shows you how easy it is to remove the Nile for maintenance, and it's just as easy to put back in. So let's see if it'll play. See, they just quickly took it out. Now they can do the maintenance really quick and life is good and they can put it back. So with some simple data commands after they reinstalled that sensor from a data logger, the Nile is going to begin to record accurate data again just really soon after that install. So finally, the Nile can be used to monitor storm surge during hurricanes. Since these radars can be mounted above the highest level of storm surge heights on existing infrastructure, there's actually no worry that the units are going to be flooded, and accurate data can be collected before, during, and after hurricane events. So through the collection of this data, emergency management can plan best where they will need to deploy to save lives and property. And there can, of course, also be a lot of studies done too to see what the effects on the ecosystem are. And Michael, I think we are ready for another slide. I think they've had enough of me talking for just a minute and would like some engagement.
Thanks, Kerry. Certainly educational and very informative. Thank you. Our second poll question is, please indicate which water level sensing technology you predominantly use. Submersible, shaft encoder, bubbler system, radar water level sensor, or other. Again, for those of you who have come on late and are not sure how to use the poll question, simply move your mouse over one of the answers and still just simply click with your mouse on the answer you'd like to respond with. So just give our audience a few seconds to respond. And I'll take this opportunity just to remind everybody that there is a Q&A, a question and answer period that will be scheduled for the end of the webinar. Once Kerry has finished presenting her presentation, we will be opening up the Q&A session. And at the bottom right of your GoToWebinar interface, there is in fact a question chat section. Simply type your question in there and all the questions will be queued up and we'll be taking them one at a time. So feel free to load those questions now or throughout the remainder of Kerry's presentation. All right, Kerry, it looks like we've got most of our responses. Let me just share those with the audience and yourself. It looks like 50% of the audience have answered submersible pressure sensor.
Interesting. That's really some good information. What is our next most popular there, Michael?
Yeah, it's actually 24% with other.
Oh, interesting. I'd be curious to hear what those other types of sensors are. So maybe you guys can pop that information into the questions panel that Michael was just talking about. That'd be fantastic to learn about.
This is followed by radar water level sensor at 18%, and then 5 and 3% for bubbler and shaft encoder. So it looks like submersible pressure sensor is the level sensor that's predominantly used by our audience.
Excellent. Well, thank you very much for sharing that. And we will pop back into the presentation here. And now section 5, we are done with our precision sensors. So now I'm going to talk a little bit about our Storm 3 data logger as a telemetry solution for you guys. So the Storm 3 is a mid-range data logger that supports cellular or satellite telemetry options. So this logger is unique that it comes preloaded with a built-in sensor library for easy sensor setup in the browser-based graphical user interface. So just like the Amazon, you can connect to the Storm 3 using Wi-Fi or a device cable. So as you can see here, the Storm 3 allows for the connection of analog, digital, and SDI12 devices. There's also ports for RS-232 and RS-485 sensors to be connected. So when that little Wi-Fi button right there in the middle is pressed, if you do have a Wi-Fi adapter attached, a user can connect to the Storm 3 using a laptop, a tablet, or a mobile device for easy programming, either in the internet browser of their choice. And there's also USB options for connecting through a device cable and also for transferring data to and from the logger. So this is what the main menu of the Storm 3 interface looks like. So the Amazon interface was actually based on this design. So you might see they look pretty similar. So therefore, if you know how to maneuver through the menus in one instrument, you should be able to in the other, which is pretty nice. So when you connect to the instrument through cable or Wi-Fi, you navigate to the IP address listed there on the right-hand side of your screen if you're not directed there automatically. And that's how you get to this screen. So in these few images here, you can actually see how simple it is to actually add a new sensor. So the user clicked on the Sensors tab on the left-hand menu here, found their sensor from the drop-down list and added it. And now it shows up in the sensor menu on the left. So we see we added a Nile radar. Next, the user would select that sensor and check the boxes indicating which parameter they would like to have logged, either internally, telemetered, or both. So in this case, we chose stage. So once the parameter is selected, it also appears in the list, and that's what we have zoomed in on here. So from the sensor menu, it's really simple to configure. So you can change the SDI12 address, you can view wiring diagrams, you can get live readings, and If you scroll down, you can actually choose how you want that data logged. Do you want it logged internally? Do you want it telemeter? Do you want it through Modbus? And more options. So when you navigate to the Output tab, as seen in the image on the right here, you can see that the selections that were chosen in the sensor are replicated in those output tables. So whatever's in the output tables on that tab is what's going to be transmitted or logged internally. So the San Francisco Public Utilities Commission has been using our YSI equipment for a long time, and they chose the Storm 3 because of its ease of use and its ability to transmit to the cloud-based data hosting platform that we're going to talk about here in a minute. So they're monitoring the Crystal Springs Reservoir, which serves as a drinking water source for over 1 million residents. So it's also a huge fish and game refuge for wildlife, and the state mandates that environmental conditions have to be just right for the wildlife in that reservoir to survive. To maintain the water quality that's needed, the Storm 3 transmits pH data collected by an XO2 sonde and transmits that data so that adjustments can be made to the treatment processes at the water treatment facility to ensure that the pH remains between 6.5 and 8.5 in this reservoir. So it's really important that they had that as a real-time data source so that they can make those adjustments quickly. And Michael, I think now we are ready for another poll.
Thanks, Kerry. Yep. Our poll number 3 is, please indicate what generation cellular network is currently preferred for your cellular data transmission. We have the options of 3G, 4G, or 5G. So once again, please roll your mouse over and simply click on the response you'd like to make. Our audience is jumping on this one, Kerry. Obviously, a question of interest for many.
Everybody wants that 5G, right?
They do. All right. I'll just close this up. It looks like the majority of the audience has voted. And we have 70% of the audience selecting 4G.
Excellent.
Followed by 19% for 3G and 11% for 5G.
Okay, excellent. So yeah, we definitely have a lot of 4G users, so we need to make sure that we're able to transmit for 4G for sure. And we do have that ability, so that's good. So hit your salesperson up for some additional information on that one. So the last section that we're going to talk about is tying all these pieces of instrumentation together in a nice little software package that's going to allow you to visualize your data. So HydroSphere is our new web-based data hosting platform that's going to allow you to easily visualize your network and sites of data. So in this first image here, you can see how quickly that an issue with a pollution source could be spotted, how quickly fouling could be identified, or maybe potential algae blooms could be monitored. So graphically viewed data is a tremendous help when it comes to spotting trends and issues in data. And having the ability to view this data from your computer at Starbucks, your office, or maybe your couch at home can really help you determine if a visit to your site needs to take place. I know with a lot of us being shut down because of coronavirus and those kind of things, it's really important that we can monitor these things remotely so that we can decide if and when it's really necessary for somebody to go out to the site. So, and HydroSphere can also be your behind the scenes friend and can alert you if something goes wrong without you having to continually look at the data too. So we're going to go into a few examples of this in just a few slides, but just know that with this tool, you can get alerts to if anything that you don't want to have happen at your site actually starts to happen. So this little site right here, I'm a little partial to it. This is the one that I run on a regular basis now. So we have a partnership with the University of Georgia that we do some really neat monitoring at. Our partnership began last year in 2019, and the gauge itself was installed in June. So the folks at UGA have done a ton of research on this creek prior to YSI even becoming involved, because it truly does run through the center campus and drains into a large recreational river not too far downstream. So as for the site itself, it has some really interesting characteristics. First off, it's a really pretty small watershed at only 2 square kilometers. So as seen here in the map in the middle of the screen, the area is also really heavily urbanized since the creek does run in between dorms and parking garages, educational buildings, and more. It was measured several years ago to be approximately 3/4 impervious area, which means that you do have some really fun hydrology that goes along with that, especially for the urban hydrology lover over here. So talk about some flashy streams, as you can see in the image here. This site can go from base flow to basically a raging river in no time flat, since any rainfall pretty much immediately washes into the creek. You can see all these little peaks in the hydrograph here, and each small bit of rain is actually accompanied by its own water level rise and fall. Another interesting feature is that about 50% of the stream here is not even in natural channels, it's in pipes. So for example, if we look back at this map right here, we can see our American football stadium, Sanford Stadium, is located right here on the map, and the creek actually goes right underneath it. They actually channelize this and have a giant pipe that goes underneath the stadium, and that's what carries the water down to the Oconee River over here. So to measure the stream flow and rain out here, I've installed an Amazon bubbler that we discussed already. It has an H3401 rain gauge, and to telemeter the data, I have a Storm 3 data logger that does transmit over 4G. So now I just wanted to talk about some different alarms that you can trigger using HydroSphere so that you can kind of get some of those alerts that we had just talked about a couple slides ago. So the first one I want to talk about is actually battery voltage. So battery voltage can decrease over time thanks to bad weather, bad wiring. Maybe your solar panel isn't working correctly, or maybe it's dirty. Maybe you blew a regulator. There's a whole bunch of different reasons as to why your battery voltage might go down. Now, if the battery voltage does get too low, your data logger will stop transmitting. So before that happens in my case, I want an alert that tells me that my battery is getting low. At UGA, and as seen in the image here, when my battery voltage reaches about 11.5 volts, it stops transmitting. So some sites that don't have as much equipment as mine may be able to transmit at a lower battery voltage. So just know that my number here is an example, and you can actually determine this for your own site as well. My alarm that I have here is simply to tell me if the battery voltage gets less than 11.7 volts. So if that battery is at 11.7, I typically have a day or two to get out to the site to replace it. So this alarm really is an early warning alarm for me to plan ahead so that I don't miss any data transmissions. So the next alarm that I want to talk to you about really causes a pretty significant road trip for me is the sensor not working. So it's of course important for us to know if our sensors are working, and our real-time telemeter data can prevent any surprises that unattended logging would give. So the default values transmitted to HydroSphere are set up in your data logger, and in the case for my site with the Storm 3, the default is negative 99.99, and you can see that in the picture here. In my example, again at UGA, I want to ensure that my dissolved oxygen sensor is working as close to 100% of the time as possible because the site is characterized as being used for recreational activity. So we're looking at fish and other organisms that need to have access to oxygen in the water so that they can survive. And we do monitor those levels here in the creek. So to verify that my sensor is working, I have an alarm that's going to send me an alert if the dissolved oxygen value gives me any result less than 0. If the sensor's not working, the data logger will report negative 99.99, as I mentioned earlier, and HydroSphere is going to send me an alert that the sensor isn't working. And I can have that alert sent to me either through text message or email also. I just wanted to make sure I pointed that out. Finally, with my HydroMet sites, I need to go out there if my site stops transmitting altogether. Transmissions can fail for a variety of reasons, such as a hiccup in the cellular signal, ghost transmissions being stepped on by another logger, and many, many, many more. With the site missing communication alerts, I can know if a single transmission is missed so that I know to start looking for reasons why. Was there a bad storm that knocked out power to the cell tower? That happens a lot during hurricanes out here. Did my battery die earlier than I expected? Could lightning have hit my station, maybe fried my data logger? Things happen, but the most important thing is that I get the site back up and running. So I have my data being transmitted hourly, and there's about a 5-minute or so processing time in HydroSphere after the transmission is received in order to parse that data and add it to the site correctly. Because of this, I want my missing communication alert to trigger approximately 7 hours after my scheduled transmission window. In this case, we're looking at 67 minutes. Also, I can keep getting alerts for many missed transmissions, or I could receive a single notification. I'll also get a notification when the data is transmitting again if it returns to service without my help, which is always a good thing. As you can see here, all of these non-blue water drops are sites that have alarms triggered. Depending on what each color indicates, field personnel would quickly know what's going on with each site and how to respond. For example, the yellow drops could indicate fouling, so maybe one person could take care of those issues. Maybe red indicates a dying battery, so another person can take care of those. Having a dashboard with these visual tools really allows you for more informed decisions about how to proceed with your daily operations. And just so you know, you can set multiple alarms with a single color water drop. So by clicking on the drop itself, you can see the most recent transmission, which is going to allow you to more easily determine why that alarm has been triggered so that you can get that fast response that we all kind of want. The goal with these remote tools really is to be able to manage a program effectively while working anywhere in the world. So Michael, I could even look at your sites all the way from over here in North Carolina, and you could look at mine. So tools like these that have been described here can really be beneficial in the long run, as faster responses can allow for the collection of not only more data, but also more accurate data. And with that, I will turn it back over to you, Michael, for our last poll question.
Thanks, Kerry. That was a fantastic introduction to HydroSphere, and we appreciate their time on that. And to our audience, we have one final question to share with you, as Kerry mentioned, and this will allow us to support you with any additional questions that you might have. So would you like one of our sales representatives to contact you with more details about any of the applications or product solutions that Kerry has shared with us today? Simply let us know and we will reach out to you directly. Don't be shy. This is your chance to ask as many questions as you like directly with our sales specialist, our product specialist. Okay, and with that, I'm going to close the poll. And if we can move on to our last slide. Thanks, Kerry. This is our Q&A session. This offers an opportunity for our audience today to ask Kerry any question about today's presentation. Again, if you haven't queued up your question yet, simply go to the bottom right side of the GoToWebinar and type in your question and we will get to it. If we run out of time, we do have GoToWebinar recording your question and matching it against your name, and our sales specialist, our product specialist, will definitely reach out to you via email to answer your question. So rest assured your question will be answered. All right, Kerry, there's quite a few questions already queued up that I'd be happy to share with you, and hopefully you can give an answer, a response to our audience. First question concerns the transmission of the data with the Storm Central. Can this be transmitted at the same time as an Ethernet? Ethernet, depending where you're from. Can the mode of transmission with Storm Central be at the same time with the Ethernet?
I would think that it should be able to. There's different settings in the Storm 3 that you can set up different transmission rates depending on your protocol that you're using. So you should be able to, yeah.
Thank you. Which equipment is recommended to be used in areas located in tropical and subtropical regions?
Ooh, that's a really good question. So that's really going to depend on your flow and what your setup is going to be and your type of infrastructure that you have. The Nile radar and the Amazon are going to be really good for either of those applications. If you are just if you have a stilling well available, or you have an ability to create one or build one, then for sure either the submersible pressure transducer or the shaft encoder would also be an option. All of these are really going to be available to you in that environment.
Terrific, thank you. This one seems a bit challenging. Let me know if we should take this one offline. The GOES, G-O-E-S, satellite radio. Does this work in the Philippines? Are you familiar with this satellite radio?
Yeah, I do know the GOES satellite very well. I'm not exactly sure where the cutoff is for the GOES satellite. That would be a good question to follow up with the sales team, because there's also permissions and stuff that have to go along out here to the US to have permissions to access that satellite anyway. So it may be a little more complex to use the GOES satellite over cellular communication anyway. But that's a good
Okay,
question that we should follow up on for sure.
and thanks to Alan for sending in that question. Alan, we will reach out to you offline directly via email with an answer. Thanks for that question. We've got a number of questions concerning the HydroSphere. Is HydroSphere available to users outside the USA?
Yes, HydroSphere is available globally.
Okay, and on that note, can we trust that the cloud hosting for HydroSphere is also located in the USA?
It's actually an Amazon cloud hosting service, whatever you want to call that terminology. It's actually an Amazon product, so it is hosted here in the US.
Okay, and to continue on that note, this is probably something we could take offline, but the question is, how would you address the sensitivities of government users in other countries, non-US countries, hosting water data overseas and the associated privacy of that data?
Yeah, that would be something that I think we should take offline, just because I know that each government agency is going to have their little particular intricacies, and that would be something that we could discuss with our HydroSphere team and everything at a later time.
Terrific. And Harun, thank you for sending in those questions concerning the HydroSphere. As Kerry mentioned, we will reach out to you directly with answers to those questions. There's actually a question here about webinars. How often do you run webinars? It's random. We run a few each month. And thanks to Ludovic for submitting this question. Ludovic, there is a follow-up email that will be coming out approximately 1 hour after this webinar, and there'll be a link to our webinar library. Feel free to browse through them. We do record all of our webinars, and you're free to browse them and view them on demand. We also post all of our upcoming webinars, and we do invite you to register for those. All right, another question, Kerry, concerning the Storm 3. So what are the sensors that are available for the Storm 3?
So we have a wide variety of sensors in there, and I wish that I had an image of that drop-down list. So you can actually choose by different manufacturer, or you can choose by different sensor types. So we have a wide array of old former waterlogged products, such as the Amazon bubbler, the Nile radar, all the submersible pressure transducers. You can also add in your water quality sensors like your EXO or your 6 series sensors, anything like that. And then we also have the ability to add in a sensor that we may not necessarily have in our library. So we might call that a generic sensor, but you do have the ability to change the name of that sensor in the Storm 3 so that it is more meaningful for you. So really everything should technically be covered by our library. You just sometimes have to rename it yourself.
Terrific. Again, another question about the Storm 3 data logger. Is the data stored on site, or is it sent to the website, or a combination of both?
Either or. So there is a memory card inside the data logger itself that you can record the data to. So then when you go out to the site, you can take like a USB drive and download the data to your USB, or you could even, if you're connected over Wi-Fi, you can download the data either to your cell phone or your tablet or whatever it is that you're using. The other option then, of course, is that you can telemeter the data to something like HydroSphere. You also have the ability to telemeter the data to your own remote server, but there's of course some additional setup that you would have to do on that end as well. So either or, both is always good.
Terrific, thanks. We just received a comment from a member of our audience saying, Kerry, thank you for your great presentation.
Oh,
And
no problem. It's my pleasure. I enjoy doing these and talking to you guys for sure.
great. We've got a final question here concerning the Amazon. Can the Amazon use radio transmission for localization of data?
That's a really good question. I know that that's something that we have played around with, but we'll have to follow up on that one because I know that we can for sure do the internal data logging, but for transmitting outside, we typically have users connect to a data logger, but I know there's an Ethernet option if that's a possibility for this site. So we may need to follow up with a few more details.
And how many sensors can each unit hold for the concerning the Storm 3?
Oh, it can hold a lot of sensors because you can always connect to a terminal strip. I don't know that there's necessarily a limit that I am aware of, but we can follow up with that as well.
Okay, terrific. Thank you. There's another goes question. Harun, again, we will get back to you offline, the direct email to your question. Great. And again, another comment here. Thank you. Great presentation. Very informative. Edmund, thank you for sharing that with us. Terrific. Well, Kerry, thank you so much for your time today. I realize it's nighttime over there where you are. We appreciate your support as always.
No worries. Anytime. I'm happy to be here, and please let me know if there's anything that I can do to help any of you ever again.
Terrific. And to our audience, a big thank you wherever you are. And again, keep your eye out for that follow-up email, which should be coming out in about an hour or so, which will include a link to the recording and then the link to the web address where you can download this presentation. Please give us about 24 hours to get the presentation converted to PDF and uploaded to our website. And we look forward to seeing you at all of our future webinars. And again, be safe out there and have a terrific day. Thank you, everyone. Goodbye.
Thank you all.